Now let's see how to use a slider, intersect tool, extremum, and then the rows are in detail. So let me delete this point here. Just click on it and delete. Using the linear function and then the quadratic function, we can see how best the intersect, extremum, and rows tools are used. I'm going to create the first slider here. Its name is going to remain as A, and let it be between -10 and 10. Again, the increment in between each point in the slider, let it be 1 unit. Then I click OK. Then I create still another slider here, B, -10 and 10, still 1 unit. Then another slider here, C, -10 and 10, then an increment of 1. So we have 3 sliders here. You can drag them and put them in some good positions so that it doesn't interfere with our graphs. You can put C somewhere here, then I bring B somewhere here, then A here. Alright, so after creating the sliders, let's go and graph the linear function and the quadratic function. Beginning with the linear function, you know the general form of the linear function is given by f of x equal to ax plus b. So this is the linear function. So a is picked from this slider, and then b, which is the y-intercept, is picked from this slider, the values of b. So you can change, for example, if you want to see the behavior of the linear function with respect to different values of a and b, so you can just drag like this. You see when you're dragging a, you see how the shape or the orientation or the position of the line is changing, or the graph. We know a is the gradient or the slope. When you have a positive slope, you see how the slanting is. Then when you have a negative slope, you see. So when the slope is 0, see what happens. The line is just straight like that. Then when the slope increases, see the line increasing from left to right. Then this is, you know, the y-intercept when you keep changing. So the position where the line cuts the y-axis changes. You see here, the value of b is -3. You see it's cutting at -3. When they change to 4, you see it's cutting at 4. Now it's 5. So you keep dragging this to different values. Now let's graph the quadratic function. Since here we already have f of x equal to ax plus b. Now here we have to define the quadratic function in a different way. Now here we're going to have g of x equal to ax. So when you want to get squared, you press shift and then key 6. Then you put your 2 there, right arrow key, plus bx plus c. So we have the quadratic function here. You can investigate the effect of changing the coefficient of x squared, coefficient of x, and then a constant c here by changing the sliders. You can even animate. If I click this, I click that, I click that. You see, it's like a video now. So you see how the changes take place. We can even do them one by one. We all know that when a is negative, the graph curves downward, or it makes some sort of an N shape for the quadratic function. Let me first bring b somewhere here, then c somewhere there. So when I change a, you see, when it's 0, it becomes a straight line. Then when you move it to positive, you see it's curving upward, U-shaped. Then when you get back to negative, you see it's curving downwards. You know, c is the position of the vertex. When you change c to 2, the vertex goes to 2. When you change c to 3, the vertex goes to 3. So you can use this to investigate or show the learners in real time. This one, you cannot do it on a chalkboard. You can do it, but it's cumbersome. That means you have to each and every time erase one graph and draw like that. But with GeoGebra, you can change it in real time. So that's how you can use the slider tool. It's an investigative tool. So let me bring the graph somewhere here at that point. Now let's see how we can use the intersect tool and then the extremum tool. So this is the intersection tool. You click on it, you see select intersection or 2 objects successively. So I want to get the point of intersection between this line and then the curve. So I click on this curve and then I click on this line. We have the intersection point A and B. You can read it off the axis here, or you just come and click on algebra. You see, you have the intersection points here. Then the extremum, you know, as I said earlier, the extremum here shows for us either the maximum point or the minimum. Like here, you know, this graph has a maximum. So when you click on this curve, you see, we have the maximum point there. Come back to algebra. It's 0, 5. So you can read of the coordinate from there. Then the roots, you see, select the function. So what is the root of this quadratic function? You click on it, D and E. Come to algebra. Can get the values of x. You see, the values are here. So this is the solution of this quadratic function. What about for the linear function? Let's try to see if we can get the roots. So the root is normally the point where it cuts the x-axis. So the root is there. This is how you can use these tools here. See how important it is in enhancing teaching and learning and representation of abstract concepts that cannot be easily done on the chalkboard. So you can now manipulate A, B, and C to see how the roots changes. What happens when you change the value of A? What happens when you change the value of B? What happens to the maximum, the minimum? So if I take A to be positive, we shall have a minimum. So that's how we use these tools